The purpose of this lesson is to take the various details we've seen so far about wire level security and to bring them all together into a demo. You're looking at the working file HTTPS deployment.txt. For convenience, this file and the other files are combined in a zip called HTTPS demo.zip, and we'll talk about the other files in that zip in just a bit. So here's a quick overview of the demo. I've taken the predictions2 service. That's a REST-style service. It's servlet-based. It supports all of the CRUD operations. We saw it earlier. And I've redeployed it for HTTPS instead of HTTP. Now there's very good news here. This redeployment requires no change whatsoever to the service code. The only thing that changes is the web.xml file. And for contrast, here's the original file. It's fairly short, so it goes from here down to here. And the gist of the file is this. Any request that comes in for the predictions2 service is sent to the predictions2.predictions servlet instance. So in other words, it's basically routing information, nothing more. Now, for the redeployment, essentially we have everything unchanged except there's a slight addition right in the middle, and this is the added section. There's a security constraint on a web resource collection, so we might have many different resources. In this example, we have only one. The URL pattern is given. This is the only thing that we might want to tinker with a bit. Basically, what this pattern says is, if anybody requests the predictions2 service, then everything in that service should be covered by this constraint. We could fine-tune this because in the deployed WAR file, we might have a public subdirectory and a special stuff subdirectory, and we might want to limit HTTPS services to the special stuff, not to everything. But to keep it simple, I've basically imposed HTTPS on the entire WAR file. My 2 cents, by the way, is that this is a better approach to take. Put everything under HTTPS because then it's less tricky. Now, under the user data constraint, you see the transport guarantee is for confidential. Basically, this covers all of the standard HTTPS services. In other words, peer authentication, encryption and decryption, that's really what confidential points to, and message integrity. So, in summary, I took the original web.xml and basically added this section here, redeployed, we're now ready to go. Now, let's turn to the client side. There are many ways to do the client. In this particular case, I've done the security part in the code itself, but I could also do this by using command line properties. I wanted to do it in the code to give you a sense of how much code is involved. The full source code, by the way, is available in the WAR file. What I've done here is excise the imports and some other code that we don't care about. Once again, the main point is to give a sense of how much code is required. So let me go through the essentials. The most essential part is we now need an SSL context. You can see that here. And we're going to get an SSL context appropriate for TLS because that's the version of HTTPS security that we're using. I've hardwired the password. We could, of course, send this in as a command line argument. And the reason for that is as follows. If you jump up here to this line, you can see test.keystore. Test.keystore is actually the key store that I'm using for Tomcat. So you might say the fix is in. Tomcat is going to deliver certificates to this client. This client is going to test certificate against the very same file, which I'm now calling test.keystore. So there's going to be a match. In production, of course, we wouldn't do this, but we're interested in the setup. Incidentally, at the line immediately above, you can see that we're using HTTPS to connect to Tomcat. Coming back down here, this password, qubits, is the password to get into that keystore file. The keystore file is then loaded into memory, basically in these next 3 lines. And then a trust manager is created, and the trust manager is initialized to this key store file. So let me take a step back. Remember that the difference between a key store and a trust store is functionality, not file format. A key store is just a file that contains digital certificates to be sent to a challenger, and a trust store is just a key store that is used to verify incoming certificates. So in effect, I'm taking Tomcat's key store, where it holds its digital certificates, and I'm using that as my trust store. So as noted, the fix is quite definitely in. The SSL context is then initialized. The first argument is set to null. If it were not null, it would be my key store, but I know that Tomcat is not going to challenge me. When we configured Tomcat for HTTPS, we saw that. Client authentication was turned off. So Tomcat's not going to challenge me. Instead, my client is going to challenge Tomcat. So for simplicity, I've left the first argument to null. The second argument gets the trust managers. In other words, this is basically the code that's going to check the incoming digital certificates to make sure they're okay. And a secure random instance is used by the SSL context to generate whatever random numbers are needed in the course of doing encryption and so on. With all of this in place, we basically complete the initialization at this line. It's a relatively short, if a bit complicated, chunk of code. That's all of the code I need to enable my client now to talk HTTPS with Tomcat. Let's now put it all together by running the demo. For convenience, what I've done is put all of the client code in an executable jar. It's called predictions HTTPS client HTTPS.jar. I run this, and it runs the standard series of tests, get all, post, put, and so on. And you're seeing the output for that code. Now, just for ease of reference, in fact, let me emphasize this by hitting the zip. I've taken all of these required files, and I've put them in a working file called https demo.zip so that everything is in one place.